Hello my dear students, this is Raman Rana here, your mathematics teacher, Cambridge International School, Dasua. Today we will discuss chapter number 17, the straight line graph. Dear students, today we will start with the chapter number 17, that is the straight line graph. So before starting chapter number 17, yesterday we have discussed about the Cartesian plane. We have discussed about the equation of a straight line, and we have also discussed about the slope of the straight line, that is called the gradient. So let's recapitulate. We have discussed that a linear equation in two variables, ax plus by plus c is equal to 0. This is the equation of a straight line in intercept form, y-intercept form. Y is equal to mx plus c, where m is called the slope of the line and or gradient, and the c is the y-intercept. So in detail we have discussed that on a graph, horizontal axis, these are x-axis, and the vertical axis, they are y-axis, and where these both axes meet, that is called origin here, and one side and the same intervals, we like 1, 2, we have discussed about the point at a particular point. Suppose a point P whose coordinates x and y, if x is equal to 4 and y is equal to your 6, so here 4 and y is 6 and x is 4. So this point here, this is the point P on the plane whose coordinates are x is 4 and y is 6. This is called abscissa, and y is called ordinate. So in order to draw a line, we need at least 2 points, like one point is P, one point Q, so we can draw one line. So if we have an equation of line, suppose we have an equation x plus 2y is equal to 5. So here we will find the solutions, minimum 3 solutions or minimum 2 solutions, and plotting the points we can draw a straight line. Now when we start the straight line graph, in straight line graph, that is useful in converting one unit into another. For example, like if you want to change one currency to another currency, so with the help of straight line we can convert the one currency into another. One more example, like temperature. If you want to convert a temperature from a degree Celsius to degree Fahrenheit, we can use the straight line graph. So let's start chapter number 17, daily life situation. We have a very good example of speed, distance and time, and in our book most of the questions in exam also are coming from your speed, distance and time. So speed, distance and time. As we know that speed is equal to distance upon time, or if we want to find the distance, distance is equal to the distance traveled is equal to speed into time, and if you want to find the time, then we will cross multiply, and time is equal to distance upon speed. So if we want to find the average speed, then the average speed is equal to the total distance traveled, the total distance traveled upon total time taken, by the object to complete or to travel that distance. This is called the average speed. So the very important concept here, that is regarding the units. We have to take the units. If along x-axis we are taking time in seconds, and along y-axis we are taking the distance, so we have to check the units. This straight line shows the relations between the distance traveled and the time, and suppose here the time, this is 1, 2, 3, 4, 5, 6, 7 and 8 here. So let it is in seconds, 1 second, 2 seconds, so on. And here the distance, that is 10, 20, 30, 40, 50, 60, so on. So if at particular time we want to find the gradient, as we have discussed yesterday also, at a particular point, let's suppose here this at 2 and up to 5 here, this is t, this is the time interval, and here that the distance traveled. So the slope or the gradient of the line, that is defined as the d upon t, that is distance traveled upon the time taken. So here distance, that is in meter, and time is seconds. So unit of the gradient is the unit of the gradient, is meter per second, that is the speed. The gradient represents the speed, the gradient represents the speed. Speed is distance upon time. So here the small change, that is the time taken, the interval and the distance. So here this is the distance and this is the time. So the slope that is equal to the speed of that object or the straight line in this graph represents the speed of the object at particular point. Now let's take some of the examples based on your speed, distance and time. If we have given the time and distance, we can find the speed, or if we have given the speed and distance, we can find time, or if we have given speed and time, we can find the distance. So we can take some of the questions from the book chapter number 17 based on your speed, distance and time. We have a first question. Find the average speed of object moving, first part, 30 meters in 5 seconds. So here distance is given, distance is 30 meter and time here is 5 seconds. So we want to find here the speed, the average speed. As we have discussed, the average speed is the total distance traveled, that is 30 meter, and total time taken is 5 seconds. So the average speed that is equal to 6 meter per second. So next one, B part, here that is 50 kilometer in 2.5 hours. So again the speed is equal to 50 kilometer divided by 2.5 hours. So here when we divide decimal, if we remove the decimal, then it is 500 divided by 20. So units, that is 20 kilometer per hour. So here when we remove the decimal, it will be 0 here. 25 ones are 25 and this is 20 kilometer per hour. That is the average speed. And the last part, here again we have 400 kilometers in 2 hours 30 minutes. So again 2 hour 30 minutes, we need to convert 30 minutes into hour. So we can write here that 2 hours 30 minutes is equal to 2.5 hours. So again the average speed in this case is equal to 400 kilometer upon 2.5 hours. So remember here both the duration that is same, but here it is 2.5 hours. Here we need to convert this 30 minutes. 30 minutes is half. 30 minutes is equal to half of hour, or that is 0.5 hour. So here again, when we, in this case, when we convert, when we remove the decimal, here we have one more 0, and when we go for the division with 5, this is 8 here, and again 5 ones are 5, 5 6 are. So here we have the average speed 160 kilometer per hour. So here we have given the distance and time, we are finding the average speed. Now we will come to the next question. Question is, how far will an object travel during A part is 10 seconds at 40 meter per second. The speed is 40 meter per second and the time given is here 10 seconds. So we know that the distance traveled is equal to the speed into time. So in the first part, the distance traveled, the object traveled a distance that is equal to 40 into 10, that is 400 meters. Whereas in B part, we have 3 hours duration and at the speed of 70 km per hour. So again, here distance is equal to speed into time. Speed is 70 and the time is 3 hours. So here we have 70 km per hour. So R and R cancel, it is kilometer per hour, and here it is 3 hours, R and R will get cancelled. So we have 210 kilometer. So the distance traveled in the second case is 210 kilometer. Now the third, the C part, here we have 1 hour and 6 minutes. And here we have the speed that is 20 meters per second. So we need to convert here this time into seconds so that both the units are same. So in 1 hour and 6 minutes, so 1 hour and 6 minutes, we have 1 hour is equal to 60 minutes. So 60 into 60, that is equal to 3600 seconds, plus in 6 minutes we have again 36 seconds. So total we have to add, that is equal to, here when we add here 0693 seconds. So in these seconds, the distance travel that is equal to the speed, that is 20 meter per second, and in 1 hour 6 minutes, 1 hour we have 3600 seconds and in 6 minutes we have 360 seconds. So when we add we have 3960 seconds. So here 3960. So here that is in meters. So we have 0, 0, 12, 19, 7. So here we have the distance in meters. We can change into the kilometers also. So in kilometers we have the same distance, that is 79.2 kilometers by dividing by 1000. So here we find the distance traveled when we have given the time interval and the speed of an object. Next question is, how long will it take to travel a part at 50 meters at 10 meters per second? So we want to find the time. So here the time is equal to distance upon speed. So here we have 50 upon 10. Here that is meters and meter per second. So units are 5 seconds. So in 5 seconds that object will complete 50 meters in the 10 seconds. Now the B part, we have 1 kilometer at 20 meter per second. So here 1 unit, that is in kilometer, so we need to change it into meters. So here the time taken is equal to 1 kilometer is equal to 1000 meter, and 20, here it is meter and here is meter upon second. So meter and meter get cancelled. So here we have 50 seconds. So in 50 seconds with this speed, the object will travel 1 kilometer. Now the next part, here 2 kilometer at the speed of 30 km per hour. So here again the time taken is equal to the distance, that is 2 km, and here that is 30 km per hour. So here the distance, that is 15. So here it is 1 upon 15 hours. So we can convert, if you want to convert this time into minutes and second. So if you want to convert into this time into minutes, we know 1 hour is equal to 60 minutes. So in place of hours, we can write 60 minutes. So 15 ones are 15. So 15 fours are 60. So the time taken is 4 minutes. So you should know this conversion. So next part we have when the distance is 200 centimeter and here the speed is 0.4 meter per second. So we need to convert centimeters into meter. So here the time taken, so converting centimeter into meter, we know 1 meter is equal to 100 centimeter. So in place of 200 centimeter, we can write 2 meter, and speed here is 0.4 meter per second. So here the units will be in second, meter and meter will get cancelled. So here we can write it as 20 upon 4, so which is equal to 5 seconds. So I hope you got it that here distance is 200 centimeter. 200 centimeter is equal to 2 meter, and here the speed of the object is 0.4 meter per second. So here removing the decimal, we have 20 upon 4. So the required time is 5 seconds. Now last part again we have, that is 1 kilometer and the speed is 15 kilometer per hour. Same, the time is distance traveled is 1 kilometer and here it is 15. So again we have the same calculation, which is time is 1 upon 15 hours. So directly we can write it is equal to 4 minutes. So now we will discuss about the travel graph. Travel graph. So the graph of an object moving with the uniform speed is always a straight line. As I have discussed, the distance time graph here along y-axis if it is time and along y-axis distance in meters. So this distance time graph here time t and the distance d. So here the gradient means the slope, which is equal to d upon t, and as we have discussed its units are meter per second or meter per second. So the gradient represents the speed of an object. Let's take a graph here. If we have a time here, like it is 1, 2, but this time is in seconds, 3, 4, 5, 6, 7, so on in seconds. And here along y-axis the distance in meters, but here we have, this is 10, 20, 30, 40, 50, so on. If we have a slope of a line here, if it is asked that how much distance it will travel in 3 seconds. So in 3 seconds, it will travel 30 meters. In 1 second, it will travel 10 meters. In 2, 20 meters. So if it is asked about the gradient, at any gradient is here, if let the distance travel is let 40 meters. So here in 4 seconds, so distance traveled here, that is 40. So gradient here is 4 upon that, 40 upon 4, 40 meters the distance and time is 4. So we have 10 meters per second. So which is the gradient is, which is the speed, that is 10 meter per second. So here if it is asked that in how much distance can be completed in what time, so here we can find that if it is asked that 70 meter distance can be covered in how much time, so we can tell that in 7 seconds we can travel 70 meters, because here the speed is uniform. So in travel graph, the gradient of the line or the slope represents the speed of the object with which it moves or it is traveling. We have the speed time graph, the acceleration and the deceleration. So in speed time graph, if let time like these are in seconds, and here the speed so if we have a graph up to here, and then for the next these units, so here the straight line represents the uniform speed of an object, whereas the horizontal line represents there is no movement. Here the straight line represents the uniform speed, whereas the horizontal line represents no movement, and as we have discussed, the gradient represents the speed of the object at which it is moving or it is traveling. Now in speed time graph, let's take one graph, and here we have a time duration 2 seconds, that is time here is in seconds, 8, 10, 12, 14, 16, 18, 20, 22, so on in seconds. And speed here in meters per second, the speed along y-axis, that is in meters per second. So here it is again your 2, 4, 12, so on. This is the speed and this is the time here. Now let's suppose from 0 to 8 seconds, like it is 16 here. And for 8 to 14 seconds, this duration, this, and from 14 to 16, so these straight line represent the uniform speed. Here for the first straight line we have the time, that is 8 seconds, and the speed, that is 16 meter per second. So the first part, that acceleration is rate of change of that velocity, that is acceleration is equal to 16. At what rate that speed is changing, that is 16 meter per second divided by 8 seconds. So we have 2 meter per second square. That is the acceleration. So here the rate of change of that velocity, that is the acceleration, that is 2 meter per second. So this graph shows that the velocity from time interval 0 to 8 is 2 meters per second square. Remember, the units of acceleration is meter per second square. Acceleration's units are meters per second square. So it is rate of change of velocity. Now for this interval 8 to 14 here, up to 8 seconds, we have this slope. So here there is no change, but from 14 to 16, the interval, the time here is 2 seconds, and again the distance is 16, that the 16 units, the speed is 16 units. So the acceleration, or we can say the acceleration, that is 16 divided by 2 is equal to 8 meter per second square. So this is the concept of your acceleration and deceleration. So dear students, you can solve the exercise based on this straight line graph. Draw the graph and always convert the units in a proper way. So all the best, stay safe, stay healthy. Thank you very much.